All right, welcome back, everybody. Shout out, Alex. Hope you're feeling better. Okay, section 2.8, day 2. This should be day 2. Oh, that's right. 1 year I had to teach it all in 1 day, so we just did. I just had 1 sentence. But this is section 2.8, day 2. Solving absolute value equations and inequalities. We just went over the homework. We just took a look at the answers and remember that was just compound inequalities using the word and or conjunction versus disjunction. And then we took a look at just solving absolute value equations. That's it, just solving absolute value equations. So now, today is going to be more absolute value inequalities. Let's remember what an absolute value really is. Absolute value is distance away from 0, and distance can never be negative. That's our kind of formal definition. That's what, if I ask anybody, what's the definition of absolute value? Distance away from 0. Distance away from 0. Okay, and we took a look at the whole number line thing yesterday when we talked about equality. We said, okay, what values are 3 units away from 0? If the absolute value of x was equal to 3, what values are 3 units away from 0? Well, positive 3 or negative 3. We had that disjunction, the word or. But what if I changed that now? What if I wanted only values that have a distance away from 3, or sorry, excuse me, have a distance away from 0 less than 3? Less than 3. Well, think about it on a number line. I could reach down to negative 3, or I could reach up to positive 3, and I would have all numbers in between them, right? That is an idea of a conjunction. That's the and inequality. The absolute value of x is less than 3 are the points that are less than 3 units away from 0. The solution is a conjunction. It would look like this. You see it on your guided notes there, right? If I've got an open circle, that means it was just a less than. If I had a less than or equal to, it would be a closed circle. So what I'm getting at here is if you simplify the absolute value, get your absolute value on one side, number on the other, and it's a less than symbol, it's going to be an and inequality. It's going to be a conjunction. Okay? It's going to be a conjunction. On the opposite side of that, if I had the absolute value of x is greater than 3, that's saying I want distances greater than 3 away from 0. Distances greater than 3 away from 0. Okay, well that would mean I want 4, 5, 6, 7, negative 4, negative 5, negative 6, negative 7, right? 1, 2, none of those would work because those would have distances less than 3 away from 0. So I only want distances greater than 3 away from 0. That's why this is an or inequality. It could be one or the other. I could be negative 4, I could be negative 5, that would work. I could be positive 4, I could be positive 5. Still following the rules of the open circle or the closed circle, okay? But now if I've got a greater than, this is actually an or. It's a disjunction. Less than means a conjunction. Greater than means a disjunction, okay? The book thinks it's so funny. They think they're hilarious. They say great or, get it, like greater, great or than or equal to. That's the or inequalities, right? If you've got a greater than symbol, like the absolute value of x is greater than 4, they say great or to remind you that it's an or problem. That's not how you spell the word greater. We all know that, right? Okay, good. Great or less than. Less than, see that? So if it's a less than symbol, it's going to be an and inequality. It's going to be a conjunction. If it's a greater than symbol, it's going to be a disjunction. So take a look here. Solve the inequality, then graph the solution set. We're on the back now. The absolute value of negative 4q plus 2 is greater than or equal to 10. Negative 4q plus 2, absolute value of that, is greater than or equal to 10. All right. So my first step would be to get my absolute value completely alone, right? Would be to get my absolute value completely alone. Is that done for us here? Yes. Perfect. Right? My absolute value is alone on the left side. Now I can decide what type of problem I have. Do I have an or? Do I have an and? What's the symbol? Great or, right? So this is actually an or problem. Now, how do we come up with our two solutions then, right? We talked about inequalities. You just take the positive and the negative and done, right? Kind of the same thing, but you have to be very tricky, or not be very tricky, be very careful about how you come up with your second solution. The first one is as is. Now, remember what we talked about. Remember that we said we could have had this inside here, and if that was an equality, it could have been 10 or negative 10, right? This inside here could possibly be 10 or negative 10. So when I shift the inequality over, when I shift the negative over to the other side, I do still make this a negative 10 on the other side. And this stays a negative 4q plus 2. But when I shift an inequality over to the other side, what do I have to do with the symbol? I have to flip the symbol. Okay. So in equalities, whenever I talk about an equality, you just make the other part negative, right? Your two solutions would be the one negative, one no positive, and then solve. When I talk about an inequality, that's when you have to leave one as is, but the other one must be negative and the symbol must be flipped. Okay, so now let's solve this. We subtract 2 from both sides. We get, again, why do I keep doing that? I don't need to show all that work, right? Divide by negative 4. Q is less than or equal to negative 2. Right? Don't forget to flip the symbol there, too. We subtract the 2 over to the other side. I get negative 4Q is less than or equal to negative 12. I divide by negative 4. Q is greater than or equal to 3. Okay. Now we have to think about this. Are my ORs actually pointing out? Because if they weren't pointing out, if maybe they were, if my ORs were accidentally pointing in toward one another, that would be a special case. Maybe in all real numbers, maybe no solutions. We'd have to think about it. Q is less than or equal to negative 2. I'll just draw out a number line here. Less than or equal to negative 2 would be a closed dot at negative 2 pointing to the left. Greater than or equal to 3, closed dot at 3 pointing to the right. So these ORs do point out. So my full solution is Q is less than or equal to negative 2, or Q is greater than or equal to 3. Okay, let's take a look at the next one here. Well, why don't you guys do that one? Oh no, this one's kind of weird. Why am I saying that this is weird? Because of the 0 thing that's happening right here, right? If I add this 3 over to the other side, I get the absolute value of 0.5 R is greater than or equal to 0. Okay, so we have to think about this a little bit. Is this an and or an or? Or, great or, right? Greater than or equal to is an or. Okay, that means I've got first one as is. The second one, we would flip the symbol, change the sign. So 0.5 R now would be less than or equal to, would it make sense to write negative 0? No, it would just be 0, right? Okay, well, if I divide by 0.5, doesn't matter where, we get 0. So what are my solutions here? I have any number greater than or equal to 0, or any number greater than or equal to 0, or any number less than or equal to 0. All real numbers. All real numbers. If I ever asked you to graph, or if you wanted to see a graph of that, you could really put this closed dot anywhere, but I'm going to reinforce it with the 0 point here, going to the right or to the left. All right, why don't you guys try that one? What would I do to get the 2 out of the way? Multiply. Okay, good. I just want to make sure. Multiply by the 2 before I start doing anything else. Multiply by the 2 first, and then create your 2 solutions at that point. Okay, so we multiply that 2 over to the other side. I get the absolute value of x minus 5 is less than or equal to 8, right? Okay, now here I make my two solutions. But in this case, is this an or? No, this is an and. Now I'm going to write the word and here, but in the end, I'll combine it back together. So we've got x minus 5 is less than or equal to 8, and x minus 5 is greater than or equal to negative 8. Okay, don't forget to make your two solutions. This always happens. We get to this next test, like our final chapter 2 test, and people always forget the second solution. They just like solve it with no absolute value in there. It's like, oh, I have to take out half the points because they're missing half the solutions, right? We add the 5 to both sides. So x is less than or equal to 13. And add the 5 here and here. X is greater than or equal to negative 3. Okay, so x is less than or equal to 13, but still greater than or equal to negative 3. That's my solution. Remember that you should always be able to read it inside out. All right, so looks like I got a number line down here. Whoa. Okay, let's do right there. Here is negative 3, closed dot on negative 3. And here it looks like to be 13, somewhere around there. Oh, closed dot at 13 as well. Connected in the middle. Then do a question. Stretch out. Remember that you could plug in any value that's covered underneath the arrows, and to make sure that you have the correct solution. So like I wanted to plug in 0, plug in 5, plug in 10, whatever you wanted to there, you could check to see. So if I did plug in 0, 0 minus 5 is negative 5. Absolute value turns it positive 5. 5 over 2 is 2.5. 2.5 is still less than or equal to 4. Okay. Go ahead and try that one. First off, can I distribute in a negative 2 into an absolute value? Can I ever distribute into an absolute value? No, that doesn't work the same. Right? It's not like a parenthesis or bracket. So I guess that would mean the only thing that I could possibly do is divide it over to the other side. Right? I would divide this over to the other side. Divide by negative 2. So that means we've got the absolute value of x plus 5. Don't forget to flip the symbol, less than negative 5. Okay, so let's keep going through the motions here. We've got x plus 5 is less than negative 5. This is a less than, and x plus 5 is greater than positive 5. We subtract the 5 over to the other side. We get x is less than negative 10, and x is greater than 0. Ruh-roh. Why am I saying uh-oh? If I go to graph this, like, can we actually put this together and say this? No, I can't. Why not? Well, think about your answer. If I go to graph this, I'm going to say here's negative 10 and here's 0. Any number less than negative 10, any number greater than, this is an and pointing away from each other. People, can any number be less than -10 and still greater than 0 at the same time? No, you can't. You can't give me an example of a number that's less than -10 and still greater than 0. I could give you an example of less than -10 or greater than 0. Yeah, because then it only has to meet one of the two criteria. But if it has to meet both criteria, nothing's going to do that. So therefore, what are my answers here? There are none. No solutions. No solutions. Guys, I could have stopped a while back. I could have stopped right here. I could have stopped right there. Why? Because anytime you evaluate an absolute value, is it ever going to give you a negative number? No. The range of an absolute value, think about it, the output, the range of the absolute value is always positive, is always greater than or equal to 0. So therefore, if you ever have a statement where you say x plus 5 or whatever, an absolute value is less than any negative number, or 0 for that matter, it's just a no solution right off the bat. Done. No solution. That also means, like, I know we don't have an example of it, but if I gave you an equation like this, let me get a new page, let's say this, -2 absolute value of x minus 3 is equal to 10, right? If I had to solve this equation, divide by -2, divide by -2, absolute value of x minus 3 is equal to a -5. I can stop there. I can stop right there, because will an absolute value ever equal a negative number? No, no solution. There is no solution for that. You could go through the motions and you would see that the equation would give you an answer, but if you plugged in your answer back into the equation, it would not work. What's called, and we'll talk about these like the rest of the year, it's called like an extraneous solution, something that the equation makes it look like it has a solution, but that calculated solution is not actually a true solution of the equation. Got to watch out for things like that. Okay. So that's our lessons on absolute value equations and inequalities. There we go. Let me stop the video. Like and subscribe, please.